Hey guys, Alan from Hack Gadgets here. Today we're going to take a look at something a little different, or maybe a lot different. It's one of these Freshmatic AirWick sprayers. So this is one of those things that you can mount in your house, and it gives your room a little mist of fragrance every now and then. Has a little adjustment knob on the back here to adjust how much and how often you want it to spray. And you know, this isn't something I would normally take a look at. Here's the box it came in. But I was really intrigued when I saw this. It says if the red light is flashing immediately after the first spray, the refill has not been identified as an AirWick refill and will not work in this device. What the heck are they doing? Does that mean that some of these knockoff refills you see around won't work in here? I think that's what it's saying. So I don't really like that. We're going to find a way to bypass that protection. We'll see how it works first, and then absolutely we're going to crack it. Okay, so here's the device out of the box. Here's the can out of the box. I think this one actually came with two cans. I'm not sure where the second one is, but they're both identical. And here's the actual box it came in. So this is the value pack, AirWick Freshmatic. What else we got here? Don't let your pets or children eat it. And it also comes with batteries. And this thing was ridiculously cheap. So, you know, I guess they're basically giving these things away at a very inexpensive price to get you hooked on it. And you know, I guess they want you to use these just like the, you know, inkjet cartridges. You know, they don't make money on the printer, they make money on the inkjet refills. Well, I guess this little can of fragrance is the inkjet cartridge of the sprayer world here. Okay, so let me see if I can find the crazy instructions here. So C, let me find a pointing device. So C right here, that's the crazy stuff. If the red light is flashing, don't even try to use it because, hey, you got a knockoff refill in there. What else we got? Okay, that's just stupid standard instructions. So let's plug this thing in and let's see what it actually does. Let's crank this little dial up. So this is the little dial here that shows you if you're going to have, you know, lots of spray or just a little bit of spray. We'll keep it on a lot right now. There's the little sprayer, and there's really nothing to it. Like, there's a little opening thing here, and there's two batteries on either side here. Little warning here, and there you go. There's a warning right there also. So it says it's only going to work with AirWick refills. And okay, I got some bright lights in here, but already it's flashing red. And I saw that it did want to take a little spray there. And I guess what caused that? I guess this thing maybe twisting over here caused it. Okay, so I've seen the instructions before. It says to, if this thing is down, which it is, to push it up. I'm going to crack open the top of this guy. Here's the refill. I'm going to pop it in. And let me just power it down. Going to remove a battery here. We'll power it up, and hopefully I don't get schmutz all over the camera. Let's just see what happens. I'll tilt it that way maybe. I don't know. We'll tilt it this way. There we go. So it gave it a push, and do we have any flashing lights? No, we don't. Okay, so let's try that again. I'm going to remove the battery. I'm going to remove this thing. Let's just see if it knows if this thing is out or not. I'm going to put the battery in. And we'll wait a bit longer again. This time we can actually take a good look at it. Let's see what happens. There we go. So it tried, and now we're flashing. Can you see that flashing with this is closed? Kind of. I guess it flashes in the little hole here when it's closed. Okay, so it has some smarts to detect if the can is in or not. There's a little lever now, it's pushed down. Okay, and there is a sensor just on the inside here. There's something there I can see. I'm going to push this back up again. I'm going to remove the battery. Okay, and I can see there's 2 screws. Let's pull those screws out of there and let's take a look at what we got. Okay, so I love the fact that there are Phillips screws in here, 2 screws. And once you take the screws out, it doesn't just pop out. You actually have to snap the sides a little bit. I've already done it. And you'll see there is actually a little catch on the side. And I'm not sure if there's one on the other side. Yes, there's a catch up here on this side. And the whole module comes out as one. Okay, so we got nothing in here other than guts now. Let's put this aside. And here is our module. Okay, so we got some gears there. I have a DC motor here. Here's our little spray control wheel. So what is that doing? Okay, so that is ratcheting. If you can see inside there, there's a ratchet here, and it's sliding this portion of the ratchet, and that is actually sliding a switch in here that's mounted on the circuit board. Let me see if I can get a bit of a closer angle on that. We'll take this apart a bit further and we'll be able to take a closer look at it. Yep. Losing some screws here. Okay, so we have a pluggable connector. I'm really surprised about that. And this pluggable connector is going over to this little piece of magic here. So this little piece of magic, let's see what it lines up to. Okay, so this goes in like this, and there we go. So I think that's their protection. 2 little black lines mounted on here. So I'm thinking that's probably a photo sensor, and it's just seeing the difference between white and black. Actually, no, it'll be something a bit more than that. It'll probably be a some sort of emitter and receiver, because I'm assuming they can't rely on ambient light for detecting. So they probably have their own infrared light, I'm assuming, and then they shine that on these stripes here, and they're probably reading it back. So that might be an interesting sensor, and it is a 4-wire sensor. So there's 4 wires that go over to that guy. So yeah, that'll be something interesting actually. Okay, so we've got some more screws that we can take off the back here. And you know, construction of a throwaway device like this, it's actually quite nice. Yeah, I like it. This is interesting. So this is one side of the battery connector. This is positive. So how is this? Yeah, so here, this is system positive right here. It jumpers over to here. This is negative of the first battery. And we can see this actually just jumpers over to positive of the next cell with this little yellow wire here. So it just gets soldered directly to the back of this one, and this just runs over in here and gets soldered to the back of that one. And then we have a white wire over here, and that is system negative. So this is a 3-volt system. This is negative of the system. This is positive. It's funny, they have a strange color coding here. I would have expected just a single red wire on here, but they've taken a black wire also. So red, this goes directly to the motor. So they're switching the negative on this motor, and there is a little plus on the motor here also. So they probably have an NPN transistor that's pulling this to ground on activation. And why they're using a black wire coming over to here, I'm not sure. If anything, you would think they would have two red wires. And that just goes to the bottom of this board here. Okay, so let's take these 3 screws out and let's see how much further we get into this thing. Okay, so these 3 screws are out. And I like this. These 3 screws are actually, I got a time written on my hand there. These 3 screws are the same. The issue is the first 2 screws that came out, they're not the same. One is a self-tapping screw and the other one is more of a machine screw. Again, I'm not sure which one is which. I do know that the machine screw came out second, so I think it was in this position here, but come on, they're tapping this into a piece of plastic. Why not use the same type of screw? Unless this is just, you know, just laziness or something, because it's going into the same type of material here. They could have used the same screw. That's just ridiculous that they didn't. Okay, so this is all taken apart. Let me just zoom the camera here a little bit so that I don't have to lift this up. Okay, so first thing I'm going to do is take off this little wheel here. So it looks like I can just sort of press this a little bit and there we go. That just pops right out. Okay, so this is just a small little wheel here with a couple teeth on it. And again, this is the portion that sticks out the back here, and that just allows you to dial in what fragrance you want. Okay, so now that that is out, we can probably remove the teeth that it turns, or that it pushes, maybe. Maybe not. How about the motor? Does that come out now? No, sir. Okay, let's loosen up some of these wires first. You know, cable management is actually really nice on this device. They could have just tossed everything in here and just let it flop around in the breeze, but you know, they went above and beyond and actually did some nice cable management with these little clips here. There's another clip right here. But I guess if you're molding it anyway, and there's a third one right here, might as well do it. Okay, so I'm going to pull this connector out. This connector is the one that was going to that front unit. And, you know, beautiful. They actually connectorized something instead of soldering it directly onto the board. You know, this is probably more accident prone, or not accident prone, but more prone to having some issues than just a soldered in set of 4 wires. But whatever. I like connectorized things because it makes it easy to take apart. Okay, so now we have a bit of room here. Hopefully I can disassemble this without actually breaking any wires. Okay, so the motor comes off, a couple gears fall out. There we go. And the motor actually has a bit of weight to it. It's seems like a decent motor. Spins nicely. Okay. Let's remove these 2 gears. Okay, and here, this is the red gear that actually does the business here. And there is a bit of grease on here. You can see on my fingers that they're actually a little bit slimy now. Okay, so I'm kind of slippery and slimy. It's kind of gross. So there's the actual gear that does the business. There's the little pushing finger. Let's see if it'll focus on there. A nicely machined piece of plastic. And obviously no bearings. It just sits on a couple posts and spins. That's kind of what I would expect. And here's the actual ratcheting mechanism. So it's just flipping this little switch here into a couple different positions. That's actually quite a nice little method I would have thought they would just have something sticking out the back with a little, you know, just to actually flip this manually instead of having a little wheel that turns, but I like it. And that just pops right off. Has a little notch there for the actual little thing that sticks out. And we do have some labeling on the board. Not much. Okay, so we have some unit information here. An RU safety label, 94. That is, I think, the fire rating of the board. And I thought that was fire rating for FR4. So actually, this does look like FR4. I thought for a second it was phenolic, but I think it is FR4 board. Okay, and we have some sort of probably batch number here, and M negative. So that's motor negative. And positive of the motor again is just connected directly to the 3-volt positive. Wow, so this is it for the board. So on the back of here there must be a transistor and some sort of timing circuit that's connected to this switch here. Okay, so and the switch says in this position it says off. And right here it says max. So it does give us some information on here. And it looks like this thing is snapped in. Let me see if I can unsnap it. Okay, so it lifted off of those pins, and ta-da! We have some electronics in the back. And there's actually much more to this board than I thought. So this thing just actually came off of those pins. There was one little clip right here that needed to snap off, and then there we go. There's the back of the board. And there is a ton of electronics back here. I really didn't expect this detail of electronics, this level of electronics. So we have a chip on board here under some epoxy. We have a number of surface mount LEDs, one surface mount LEDs, a bunch of resistors and capacitors. We have a diode over here. And this one here, Q1, I'm betting that's the transistor that kicks negative onto the motor. If I were a betting man, that's what I would think that was. And then here's the actual connection that goes over to this guy over here, the little sensing circuit. Let's see if we can pull that little sensor out of there. Okay, and it looks like this thing just pulls right out. It's a little wiggle. There we go. Okay, and this is already connectorized, so this is completely disconnected. So what do we have on here? We have some nice labeling. And so on this side it's just connections and labels. And we can see that the actual device is a through-hole device. We can see the 4 pins soldered in there. And it looks like there is a location for a capacitor that's not populated, a surface mount capacitor. We got some weird lettering on there, so these pins are labeled as, I'm not sure if this makes sense to anybody. Actually, no, sorry, that's just a model number. Probably a model number to this board. Okay, and here's the business side. So on this side we have lots of information again on the silk screen. 349S, that's probably a batch number. And we have WP. That's funny. So I guess they wanted to really make use of this board, so they wanted to put sensor on here, so SE, and then Ensor is there. Okay, so we got R12, it looks like. And then we have KCAE. And then some crazy symbol down in this bottom corner here. Not exactly sure what that is. And you can see how small this is. This is a tip of a ballpoint pen, which actually looks quite large in comparison to this little device here. And let me see if I can get some light on this device so we can actually see. Let me see if I can get it to focus with some light. There we go. So we can actually see that it looks like there's 2 windows in there. So what I'm assuming is that one of these is an infrared diode, and one of these is probably an infrared transistor. And by diode I mean LED. So an infrared LED and an infrared transistor that watches for the bounce. What we can do is we can hook this up to the scope and we can see what sort of signals we get out of here. Because it looks like, I'm assuming that, you know, this here, oops, that this and this is one part of the package, and this one is the other part of the package, you know, in the same package but two separate devices. But we can determine that. And I think I was wrong in my initial assumption that that transistor was the one that pulled the motor to ground. I was thinking it was this transistor here, Q1, but lo and behold, there's actually another transistor up here. I didn't see it, labeled Q2. And it looks like, I'm not going to trace this out because it's not really worth it, but it looks like this pin here is connected over to this guy, which goes over to this blue wire, which is the feed to the negative of the motor. So yeah, I'm thinking that little transistor is what's activating the motor. So I'm not sure what this other transistor is for. You know, maybe it's, well, it's very close to this header here, so maybe they're actually using it to drive the actual infrared LED, if that's what it is. Or, you know, maybe they're also using it just to drive this little LED down here. However, you know, this LED down here is probably only running at 2 or 3 milliamps, just for a flashing light indication. So I'm assuming that whatever type of onboard device they have there, it probably can drive, you know, 5 or 10 milliamps directly. You would think anyway. Okay, a little bit of Googling and check this out. There's a Vishay device. It's a reflective optical sensor with transistor output. It's the TCNT 2000. And so that's what the device looks like, exactly like we got. And there we go. So we have an IR device in here. We have an IR transistor here. So they just show it as a transistor. Oftentimes you'll see it with squiggles going in, and this would normally have squiggles coming out, indicating it's an LED. So that's a device that when IR light comes into this window that's on the front here, it actually hits the base of this, activating the base and then allowing current flow through this device, I guess, in this direction. And this device, when we pass some current through here, this is just an IR LED. And so what do we got here? It's a reflective sensor, miniature SMD package, infrared wavelength, 940 nanometers. Okay, so that's a bit of information there. You can pause this and read that if you want. Wow, the sensor has a built-in daylight blocking filter. Well, I guess that's just the material that they've put onto here. Just weeds out the standard daylight. Has some dimensions there. So it has an operating range, so that's pretty interesting. 0.2 millimeters to 5 millimeters. So 0.2 millimeters is actually very, very thin. So how thin is 0.2 millimeters? Well, here's some calipers. So these are pretty much zeroed out. Let me zero it. Okay, so those are completely closed. So 0.2, and I'm in millimeters there, 0.2 millimeters. Let's just see how far I have to open this. There's 0.1, and there is a little more than 0.2. Okay, so that's around 0.2. It's 0.18. That's how thick it is. How thick is a sheet of paper? Okay, so I'm closed all the way, I'm zeroed. Put a sheet of paper in here. So a sheet of paper is almost 0.1. So if I fold the sheet of paper twice, there you go. That's 0.18. So this thing can read, you know, the thickness of this away from something is what I think that means. So that is pretty crazy, actually. And up to 5 millimeters. So we know what 5 millimeters is. 5 millimeters is a typical LED. And we can see in comparison, 5 millimeters here is actually quite large. So there's about 5 millimeters, you know, in comparison to my hand. In comparison to a finger, that's 5 millimeters. Okay, applications, position sensor, optical switch, object detection. So there we go. So presence of paper in a copy machine, etc. Okay, and there's actually 6 pages to this thing. I just took a look at the first ones. I'm interested in knowing how much the IR emitter can have current-wise. Okay, so there we go. That's probably why I'm thinking this is transistorized for the drive. So the forward current, which is the second line here, 100 milliamps. So I doubt if that little onboard device is ever going to drive 100 milliamps out of the output. So I guarantee that that one transistor is driving the infrared LED on here. And there's the rest of the specs. You could pause this if you want to read those. Okay, and I'm just thinking also, now that we know what this is, the lettering on the package actually makes a lot more sense. So this is the anode and cathode of the LED, and this is the, I've kind of scribbled over here, but this is the E for emitter, and this is the COLL for collector. So what we have listed here is we have K and A for anode and cathode, and we have E for emitter and C for collector. So man, they did a nice job of labeling what we have on here. And we can go just a step further just to verify that a little bit more. We can take the meter, and this is in diode check mode right here. So this should actually tell us the voltage drop of the LED. So I'm going to put the red lead on the anode and the black lead on the cathode, and we're getting 1.015 volts. We don't get a beep because it's not a nice low diode voltage, like, you know, 0.7 or 0.5 volts, but we can absolutely read that diode voltage. Okay, so to check out the sensor a bit more, I've just soldered on and used a little bit of hot glue for some strain relief, and just so happens the colored wires I had were identical to this, so they're color coded the same as these wires here. Okay, so I think I said that this thing, the gears were actually pretty flimsy. I'm actually wrong. They're actually sitting on these nice metal pins here, and nice and smooth, well machined, and the motor is beautiful. It's really smooth, and these gears really mesh very well. So I'm actually quite impressed by the quality and the smoothness of this disposable device. And here's the plunger, so this actually just fits in here. And so I'm not exactly sure how this works, because it can spin in one direction, but then it actually gets stopped right here. So it can't go any further than this. And this is a DC motor, and the positive of the DC motor is hard connected to the positive of the battery here. So I'm not exactly sure what it's doing. I'm thinking this actually somehow reverses this motor to spin it backwards, but I'm at a glance here, I'm not exactly sure what they're doing to reverse this. So first thing, we might actually have to meter the voltage on this thing when it's spraying and see if it actually does reverse. Okay, so putting this thing in place is actually a little bit tricky. What you need to do is there's the little position sensor here, which is connected to that back knob. And these gears actually interfere with it, so you can't just drop it down straight. And these two pins line up to these holes here. So what you sort of have to do is position this little plunger tip correctly and sort of scooch it underneath that little thing there. And trying not to make anything fall out. Get that little plunger tip in the hole and then line up the guys there. Okay, so we got everything in, and quite nice. There's actually a little piece of plastic here that actually holds this down, and once this board is in, that actually holds down the board on the inside that the little sensor is connected to. So the way things meet up and mate and hold things together, it's actually really nice for something that's inexpensive and disposable. So yeah, I'm quite impressed by the construction. Okay, let's throw some screws in here to button things up. Okay, so the screws are back on for this rear module, and we can see how this hits the end stop. If we push it down, it hits there and stops, and obviously, so we're not just hitting maybe the end of the gear, but we're physically hitting this portion here, so it can't go any further. And then if we push it up, it physically hits here. So I'm wondering how this thing actually gets pushed up. Is it the force from the can? You know, when we push down, we can keep it down, and unlike a lot of spray canisters, it doesn't continue to spray. And then when we release it, and there's not a lot of force going up, so I don't think this is actually pushing that up. So the only way I can think this is going up is you know, the motor spins for a little bit to push it down, and it reverses direction to push it back up. Let's meter this with a meter and see what it's really doing. Okay, meter's on voltage DC. I'm going to connect it onto the thing here. We've just connected the battery, so it should spray at any one time here. Okay. And how did this thing end? So it did end down. And we have the LED inside there flashing, so that is the LED we saw before on the board. And it didn't push itself back up again. And if we put a canister in here, I don't think this canister is what actually pushes it up. Okay, so there is no funny shenanigans happening here with some sort of you know, reverse current somehow, or reverse voltage. I watched that last video, and yeah, it absolutely doesn't go negative. What I've done here is, so we know our motor is hard connected to positive. This is just this wire is just connected to negative here, so I can just tag the motor to force it to activate. And I've already done this, and what it's doing, I think it's pretty clever. So what I'll do is I'll activate it without anything in there, and I think what they're doing is they're relying on the sort of bounce back and maybe a little bit of assistance from this canister to actually get the thing to reverse. So it only does ever push this little lever down, and I think it just sort of bounces off of this and just relies on the inertia to come back. So we can actually activate this. Let me just get this ready here. So if I activate this here, so you can see as it goes down, it actually has a little bit of a bounce back. And I think You know, here it's actually going a lot further than it ever would with a canister in it. But if I put the canister in, I got to hold it. There's actually quite a bit of force here. So if I'm holding this gently, it will actually force the canister down in that position. So I got to hold it up with a bit of force here. And let me try to get this wire in the back. And of course it just fell out. Now, okay. Holding the wire in place with one finger, and I'm going to try to tag this and keep this in frame and hold this thing on at the same time. It kind of let go. I'm going to do it one more time here. Okay, so I'm holding this wire over to the battery connection on the other side. I'm going to try to hold this quite tight so that we don't get any slippage, and I'm going to tag the battery here. And I'm going to try to keep this in frame. Let's see if I can make it rebound nicely. Kind of. It still did twist, but look at that. It rebounded far enough, it's not actually pushing it down anymore. Okay, so this is being modified a little bit, and what I initially did is I just used some solid wire here and made some connections to those key points, but I didn't like using the, I was just going to use a pin header here, poking a pin header out and soldering directly to the back, which would have made it a bit difficult. So what I ended up doing is I took one of these dual female 6-pin to 6-pin headers. I just chopped it in half, and I just soldered some of those leads onto the existing ones that I had soldered on here. So the points we're monitoring are basically all 4 points for the sensor here, and we're monitoring the positive negative of the motor. And so those are all just brought out to this header, which will just be, when it's closed up, it'll just be poking out the side there. And that's just been hot glued in place. Okay, so I'm going to pop this back in place and get this all screwed in, and we'll see what this thing does on the scope. And I just thought I'd mention this nice piece of mechanical engineering here. Overall, this thing is very well built for a disposable item. As you move this ratcheting mechanism back and forth, you have precise control of the setting you want, but it's impossible to put any undue force on the actual switch inside, since when you hit the final limit here, you're physically bottoming it out on this piece of plastic. So you have plastic to plastic contact, so there's no actual pressure on the switch, which is just beautiful. And same thing in this direction here. That's the last position, and you just physically can't go any further. So that switch is in its final position, and there's no actual stress on it. Fantastic. Okay, so we're buttoned back up again. The only difference now is obviously we have a port on the side. Pin number 1 is right at the top here, and the way it's wired up is the first 4 pins are just connected to this device here, and then the last 2 pins are connected up to the motor. So we have pin number 1 is this side of the transistor, pin number 2 is this side of the transistor, the collector, and then we have, let me see, pin number 3 is over here, pin number 4, and then we have positive and negative of the motor is the last 2 pins. So let's wire it up to the scope, and let's see what sort of timing we get out of this this IR detection circuitry. Okay, so the device is powered off, and we're going to power up here, and we're trying to capture just some IR information. Okay, so very shortly after power up, we see it trigger. Okay, so we're going to try to capture some IR information here. I'm going to turn on the power supply, and we're going to wait. Now this is in capture mode, and it's 5 seconds per division, so this might take a little while to capture since we're capturing millions of points of data here. And we might even see a bit of a delay after it activates. Okay, so I heard it try to spray. Okay, so here's some data we're capturing. And I'm assuming here we can see there's an event. That's probably the spray event. Now all we're hooked up to is just the IR LED, since on the system all we have is just a common negative and I'm assuming that the IR LED isn't on all the time, but it's looking like it is doing something very frequently. Okay, so the capture is finished. Let's take a closer look into it. Okay, so let's zoom into some of this information here. Let's just take a look at the beginning first of all. Okay, so it looks like our voltage is a bit higher at the beginning. It starts off with, whoops, and okay, so it is pulsing, but it looks like it's always pulsing. Okay, so we're at, let's see here, 2 volts, 2 milliseconds per division. So our pulses are around 2 milliseconds in duration here. And this is 5 milliseconds per division, and we got about 1, 2, 3, so, and 5 milliseconds, so that's about 15 milliseconds between IR pulses on the IR LED. And let's take a look and see what that interesting stuff was over here. So it does drop in voltage after a while. So I'm wondering if that's maybe when some internal items turn on. Okay, and here's the big event that we saw, and I'm thinking this is probably when the actual item starts spraying. So this is motor on. Here's another spike here. This is probably motor off, and then it looks like it samples for a long time after the motor is off with the LED being full on. Okay, so let's take a look at that spike here. Okay, so here's our normal sequence of pulses. Okay, so we can see we do have a spike here. This is probably the motor turning on. And then that IR LED is full on, and it stays full on. And this spike here is probably the motor turning off. And just before the motor turns off, it looks like it pulses again for a little bit, so it turns off the IR LED. And then it's on again for a good long duration after. And it looks like, yeah, we just go right back into the standard pulsing. So this is probably the sleep mode. I'm not sure why they pulse it in sleep mode, but it looks like they do. And let's just see here, how long is this for? So this is in 100 millisecond per division. So this is 1, 2, 3, 4, 5, 6, 7. About 700 milliseconds. So 0.7 seconds is what I'm thinking that motor is on for each time it pulses. And we can verify that when we hook up in a different configuration when we're actually monitoring the motor power. Okay, so I'm going to power on. I'm just going to reset that. And in about 15 seconds or so, we should hear the device try to activate, and we should see the spike here. Okay, there we go. Now let's see what we captured. Okay, so we can see we got some good information here. What I'm going to do is I'm just going to turn off the first channel, which is the IR LED information. We sort of know what that's doing. We're going to leave on the transistor output and the motor. Okay, so let's turn off the motor for a second, or turn off the transistor for a second. Okay, so here is the actual motor. Okay, so we can see this is where the motor's off. The motor turns on here. It stays on for a while and it turns off again. Now let's see how long it stayed on for. This is This is 100 milliseconds per division, so this is 1, 2, 3, 4, 5, 6, around 7. Okay, so that is how long the motor was on for. And here's the transistor pulses. So we can see that the transistor pulses start just before the motor is actually turned on. And this is transistor output pulses, so this is when it's actually taking a look at what's there, and right now, so nothing is actually in here, so it's just it's wide open. So this is what it's seeing here. So we have wide pulses. So I'm assuming this is just what we would see if there's free air, and possibly when there's maybe white in front of it, or maybe black. We'll see. And these are about 5 millisecond pulses is what we're seeing out of there. Okay, so it looks like it doesn't take any pulses right when it's actually firing. And then the IR pulses start again, and I guess what it's looking for is the barcode pattern. So this seems very consistent here. Okay, and we do see that there is some dropouts here again just before it turns off, just before the motor turns off. So you can see there's nothing here, and again this is where the motor turns off, and during the motor off period it doesn't sample anything on the IR. So this is basically the IR LED being turned off, and this is the output of the transistor, which is giving us nothing. And then it does sample for a long time after, and I guess what this is this is waiting for the rebound of that device. So here's the off period, and it's just waiting, and so it actually waits a good long period of time. Let's see, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it waits about a second after it actually turns it off for that can to have its little nozzle go back into position before it sort of says, hey, I'm in alarm. And so right now the thing is flashing red, so it didn't see the black portion in this period of time here come back into place, so I'm assuming that's why it's showing alarm. Okay, so now we have just this is the nozzle portion of it, and it's just got some white tape on here, so those black bars are no longer showing. I'm just going to place this into the unit here. We'll set it up for single shot, and we'll activate it. So it's on, so it should activate in about 15 seconds. And let's take a look and see what a white only one looks like. And this is what a counterfeit would look like. Any time now? There we go. So let's take a closer look at this capture. Okay, so let's zoom into this a little bit here. So this is where the motor turns on, and we can see, so here's the interesting pulses here. Let me just turn off the motor information. Okay, and so we still do see some pulses, but predominantly it is off. So it is opposite of the way it was when we saw it with nothing in place. And that continues all the way down. And I'm assuming this is some pulses we see here when the motor is being shut off. Let's just turn the motor back on here. Yeah, so this is the motor being shut off here, and we saw that before. So this is the important stuff here. We see no change within here. Let's put the actual one back in there, and let's see what we got. Okay, so we got the can set up with the thing back on here, the black bars. I'm going to put that back in place here. Okay, so that's been installed. I'm going to reset this. I'm going to power on here, and we will capture the entire look of what it should look like when we have a proper can in place. It's nice that this thing is consistently spraying after 15 seconds of being turned on. Okay, we got it. Okay, so let's see what this really looks like here. Let's zoom in a little bit. Okay, so black is large spaces, so we can see when we activate, this is the motor turning on. We're showing black. Now we're showing white. Now we're showing black. Motor turns off. We're still showing black. Now we're showing white. And we're finally showing black again. So now it's back into the rest position. And then eventually the IR turns off. So we're just showing a consistent signal there. Okay, and for those who want to see what the power consumption is, let's just take a quick look here. Okay, so this is on amps DC. I'm going to power up here. So there we go. And let's just wait until we actually have the motor activation. Okay, so I saw about 300 milliamps, and now we have the red light flashing. So it consumes about 300 times more energy when the red light is, the red LED is flashing than it does when it's in a true standby mode. Okay, so now we know that the protection on these things is actually just very simple. There's nothing to it. It's just exactly this. It's a 2mm black bar followed by a 2mm bar of white followed by a 2mm black bar, and that's really it. So if you find you get a can, a Freshmatic can that doesn't have the bar on it, or it's damaged, or you accidentally damage your bar, you can print out this this Hacked Gadgets sheet here. I would say print it on a paper like this, which is sticky paper. Cut them out and you have a lifetime supply of replacement barcodes to do with what you like.
For more information, go to hackedgadgets.com.